Hi guys, can you hear me and how is the sound quality? Okay, great. All right, so probably you have seen that I uploaded you another homework because practicals should happen. So that homework is related to two-dimensional arrays, so you can find that out. Yes, hi Alona and Banis. Right. So as you remember, guys, previous time we were talking that we are gonna go through several additional certain algorithms. The only thing that before we will take a look on them, we would need to take a look on what function is, because the function will be used for such solutions. So today we are taking a look on the function, and next time we will try to finalize a topic related to searching algorithms. Okay, so as a regular, I'm sharing my screen, and everyone is welcome to take a look on what I will be showing you guys. All right, so I will share my entire screen. I suppose you already can see that. Here we have our course page. So the homework number 6 is that one which I uploaded today. So again, 2 weeks for sending your solutions. And before we will be overlooking a quick sort method, maybe or might happen selection sort and merge sort. We need to take a look on what function is. Because actually those methods will be based on functions. Um, well, it's not really, unfortunately, it's just a way how it's implemented, how it can be implemented. And let's take a look on functions example, and there will be several tasks for you. Well, like all the time, I have this heading here. No idea why it appears each time, but it doesn't matter. Okay, so the function. So what is the function exactly? So it's a subroutine. Subroutine actually is the part of application, part of your program, which can be run at any time from whatever place of your app. For example, guys, you can remember that we were using a lot of functions. For example, sequence rand, then rand, round, um, maybe printf, scanf, and others. All of those are functions. And you know how we're using them in whatever place in the app. So let's take a look how we can create such things. So the first of all, here we have an example of the function that gives a multiplication result. I have no idea why here star disappeared between x and y, but we'll place the star. So how it's been structured? Idea is very simple. The first of all, we write a data type of a value, which will be the result of the function. So let's suppose we have two integer values, and we give back maybe summation, maybe multiplication, or even a subtraction between them. So as you understand, guys, the result will be an integer. So we have to predict what will be the result of the function execution. If it will be the integer, okay, then we will be capable to assign the range function result to some variable. Or we can just use that as the value. So range here is the name of the function. Okay, well, which names of functions do we know? For example, printf, it's the name of the function, so we're using that function by this name. For our range function, ID is the same. What happens next? Next, we have brackets. Well, the same like we have brackets for printf. And inside these brackets, we have to declare arguments. What does it mean to declare? Well, we have to create something like variables which will be used, which are assumed to be given by us for this function when we will run that. So range function will need x and y values. So what happens next? Next, we have to specify the body of the function. So, well, that's all the time is the block of instructions all the time, guys. And after that, we won't need to use a semicolon because a definition of function is not an instruction. It's not. Definition of function is assumed to be a construction, and after constructions, we don't put semicolons. Well, some of you might say, well, we have do while. Well, do while is a specific case. So what we have here? Here we can work quite freely, literally in a similar manner as we work with int main function. We can declare variables, we can make computations, we can ask user for printing some data, we can just print out some data on a screen, literally whatever stuff is possible there. And then if we have a returnable value data type, then we have to have a mechanism of how to return the value from function. For that purpose, we're using keyword return. And after the return, well, return is the operator. It's not a function. So after that, we can place value, not in the brackets, but just after that. And that value could be variable, could be value, could be equation, which will be calculated once it will be given back as the result of the function, and so on and so on. So some of you might say, well, we have a printf function and it doesn't give any results. Well, yes, because literally such function has the returnable data type void. And void, well, void. You know this word, I suppose. It means literally nothing. So by the void, we're not defining any data type. So we say that such function will never have return operator. It's not meant for this function. So to make story much more clear, I will apply these two functions, range and print, within a small testing code. So I will take this range function. Here I have my dev C++, and I will be placing that. Surely I will make the tabulation. Definitely for the app we need int main. That's just how it has to be. And we will give back a 0. Well, guys, I suppose you remember what was the meaning of the 0. So who can tell me, guys, what the 0 literally meant? Because in the beginning, I was telling you what's the meaning of that. So does anyone remember what was the meaning of giving back a 0? Okay, well. I suppose it was pretty long time ago. So a 0 in IT means that the process was finished without any single problem. And if the process results with some of the values, by default, and actually it just meant to be that, we have to take a look in manual, which problem corresponds to that number. For example, guys, is there any one of you who bought maybe a refrigerator or maybe a vending machine? Did you have such experience? Okay, the experience of buying some equipment, for example, a refrigerator, maybe a vending machine, maybe something else, a complicated device, in other words. So in most of the cases, maybe it could be even a TV, who knows? So in most of the cases, you guys receive a user manual, a so-called user guide, in which you can see something like, well, in case of problems, you will have some flashlights flashing, or maybe on the screen you will see error 1, error 2, error 3, and so on and so on. And then you have to take a look in the user manual, well, what corresponds to that error? Did you have such experience? Do you know what I'm talking about? Okay, so in programming, it's the same. The only thing, as developers, you guys, and I suppose I can assume you as future developers. So as developers, you guys will need to write the same user manual or a similar user manual for your applications. And you will have to say to the users, well, if process finished with error 1, it means this one. If it is finished with error number 2, then you have such error. Maybe some file doesn't exist in the system or anything else. Maybe driver is not installed, and by the error message you say to the user, well, please make the file, or maybe please copy the file from repository, or maybe install a necessary driver, and so on and so on. Well, that's the regular idea of errors. And if we have the error code number 0, we think, at least in IT and actually in the industries as well, then that error code number 0 means that error is fine. So nothing is needed. In other words, the problem code is 0, so there is no problem. So literally the same as we write to return 0. But in the same time, guys, when we run the codes, for example, compiling and that, right? Okay, here I have to put the star between X and Y, as I said previously. Somehow it was erased from PDF. I have no idea why, but okay. Printf. Oh, we don't have it in the scope. So let's include the library as stdio, if I'm not mistaken. So guys, take a look on the report of dev C++. So this report is made by the dev C++ when the application is being finished. Literally what it shows us, it shows execution time, how long it took, and actually the returned value. So return value is 0. So if you're a user and if you receive a returned value is 0, if you see that, because when you compile your app, you don't have such a report anymore. You have it only when you debug it by dev C++. That's it. So as you see, right now it's 0. If I would have something that would convince me or convince the app to finalize it with another code, for example, code number 4, you would see. So again, we have an execution of the app. It's prolonging, so execution time, plus we have the error code. So what would the user think? User would think, well, okay, I have error code 4. There should be a meaning of this code somewhere. Well, probably in user guide. So that's what users of apps do. Okay, I suppose that makes sense. So we have two functions. You see we have range and we have print. So let's run them. For example, I will run the function print. As you see in brackets, it doesn't have any argument. So if there is no arguments, we can just mention empty brackets. So and in the addition, we can even make the printout of some value. Let's say it will be the value, the integer value, and we can give the value which will be printed out as a result of the function range. So let's give two values. Let it be 2 and let it be 5. So as we know, result will be 10. Let's see what will be the printout of this app. So again, we press and execute, compile and run. Okay, I forgot about semicolon. Okay, my fault. So again, execute, compile and run. So you see, we have executed print function. It prints on the screen my function and exclamation sign. And we have the printing of the integer value, which is a range function's result with arguments 2 and 5. So as we know, 2 by 5, it's 10. So we have this 10 in the printout. Literally, that's the most thing how functions work. So are we good so far? Is it clear for us how it happens? Did you understood? Did you understand how we can create functions? Okay. So let's make a deep dive and let's try to get what else we can do with them. Okay, so yeah, here we have example of another function we can use, function poll. Literally, this function makes the a in the power of b. Well, again, mathematical function, and there are tons of such things. So the next thing we have to talk a bit maybe about the ways of definition of the function. So yeah. Here we have the code for Borland C++. So this won't be compilable. So you know, guys, I will maybe switch to my system. So you know, guys, when we compile the file, well, when we compile the project, compile has from the top and goes line by line to the bottom. So some people say, and you can find such ideas on the internet, that functions can be defined in whatever place. For example, like this, we have main, then we have functions, then we have their definitions. And that could be correct for specific compilers, like, for example, Visual Studio. But right now, I'm using, maybe you're using Visual Studio, I don't know, but I'm using more traditional compiler. Idea of this one is that compilation happens strictly from top to the bottom, and once it reaches the function, for example, print, if this print function was not compiled previously, then compiler doesn't know about this. So give us error message. Let's take. So you see, print was not declared in this code. By the way, if we will comment this print, the same will happen for the range. Let's see. So you see, range was not declared in the scope. So if you wouldn't really like to make a full descriptions, full codes of the function before the main function, and you would like just to have it somewhere in the end of the file, because such things, such cases exist, and they are pretty popular, we can make a thing which is called a var declaration. What is the var declaration? var declaration means that we are defining only name of the function and a list of arguments. Like I just did that. So as I said that I have the function range, I have the function print with all of those return values, with all of those arguments. So And afterwards, after the main block, sorry, the main function, I can literally make, or let's call it fulfill their definition. Let's see if code will be compilable now. So as you see, compilation happened without any single problem. So this approach of partly or a name, then the name of the function is called var declaration. That's the legal name of that. And for example, here you can see that in this example, the same approach was used. So int prime, and then there is the integer prime function full code. Okay, again, this code is written for Borland C++, so it's not our case. Okay, here we have something pretty similar. The only thing I wasn't able to translate these images because I didn't make them for English version, but I suppose it doesn't really matter. So sometimes we can have cases of computations that assume that a computation should execute maybe itself. So function runs itself, or there could be some computational tricks. For example, factorial function. I suppose everyone knows what factorial was. It was a number plus exclamation sign after that. Literally, idea of that was a multiplication of all values from original value till 1. So if we would have, let's say, if we would have, for example, let's suppose we will have 5 exclamation sign, right? So, well, we call it 5 factorial. So it's 5 multiplied with 4 multiplied with 3 multiplied with 2 multiplied with 1. Literally, that's how that works. So, as we understand, such algorithm can be created, can be implemented using ordinary computations. Like here we have using for loop, which is pretty fine. And actually, factorial function is pretty often appeared in, by the way, working interviews when you have to write at least 3 methods of factorial function creation, factorial computation creation. Yeah. So just keep this in mind. In the same time, guys, such method, such function could be created a bit differently. So how exactly? I will show you. I will call the function f, and I will say it will have the argument x. And I will afterwards show you the result of factorial of 5. So I will have a function f with the argument x. So I will return the value of x multiplied with f, a result of a reduced x value. So idea I suppose is pretty clear. The only thing we can remember that if we are reaching 0, well, the result will be 0, right? And it's not how it should be working. So before making this, we have to take a look if x is equal to a 1, and then we return 1. Literally, when we have x equal to 5, what happens? 5 multiplied with the result of 4, which is 4 with the result of 3, which is 3 multiplied with result of 2, which is 2 multiplied with the result of 1, which is this 1. And then all of those multiplications, they will be just, implemented. So you have to keep in mind, guys, that such functions which run themselves are called, oh, what was the name of them? I suddenly forgot. Recursive functions. Yes, recursive functions. Um, and um, and they are pretty time taken. So don't be thinking like you can infinitely make make this execution. No, different programming languages have their limits. For example, as far as I know, this C++ should be capable to allow 255 such computations. If it will be more, it will just terminate the app, saying that we're going in deep on more than it's allowed. Okay, so I suppose we can take a look what will be the result. It has to be 120. Let's see. Okay. We have to give back the value which is integer. So you see, guys, we have to change void to int. And now let's run it. So you see it's 120. Literally, that's the correct result. So are we good so far? Is a factorial computation clear for you? How we can make that using functions? Okay, awesome. So let's continue overlook things. Okay, there's just a summation. It's nothing interesting. So, but again, if you would like to make the function that gives you a summation between two values, well, you can declare that, and in the same area or afterwards, you can make its full definition. So it gives you back one value plus second value, which you are placing in arguments. Like we give A, we give B, and we give the summation of A and B. I assume it's pretty easy. Okay. Another thing is that when we use functions, we can manipulate with their arguments without any problem. Let me show you. For example, let's suppose I would have an x value, which will have a value of 5. And I will try to find the result of f from x. And there is no any single connection between this x value and this x value. We just give x value to the function execution, which will be used within a function by the name of x. So this x and this x, they're not connected at all. So let's suppose our function firstly increases the value of okay, how to make that? Okay, if it's 1 gives you 1, ice. Okay, maybe it's not the best case. Maybe let's do the following. Let's have the function increase, which basically gives you the increased value of x. So increased value by 1. So we have return from x plus 1, like this. So so what can we write here? So we can write here original value increased will be the increased value, and we have here x and increased value of x. I suppose the idea is pretty simple and pretty clear. Let's see what we will have in the printout. Well, we have 5 and we have 6. So, which means that the value which is given to the function in increase literally is being given, and it will be written into a variable. Well, we call that actually argument, into the argument we created. So, but it's only one of the cases. Or we can even rewrite this as x is equal to x plus 1. Let's suppose and nothing will be changed. In the similar manner, we'll have 5 increase equal 6, right? So literally this x doesn't affect the value, the variable's value, which value we give to the function, because actually it was written into a separated variable x, which was used as argument for increase function. But at the same time, guys, if we would make such things as called references, and reference can be used by the add sign for the variable. Yeah, so before variable we write symbol and. Okay, give me a second. Why we have? Yes, we have to put that in declaration and in the definition of the function. So in this case, when increase function will be run, well at this position at printf component, comment, then this integer x will not be created. It will be still used as x, but this x will represent the value from which the value was received in this first argument of increase function. And it could be x, it could be even something else, for example, y. Again, I would like to highlight that these names are not connected. So name of the variable, which value is given, and the name or representational name of that in a function definition, those are totally different things. So in this case, we are not making any additional variable y with data type integer, but we are working with variable which was written here as the first argument of this function, but from the name of y. So by the name of y, we will be really manipulating with this variable x. And by the way, if you have references, then it's mandatory to give variables here. You cannot just place some value like 4. It won't be compiled at all. But when it's a variable, then you can do that. So you see the code is being compiled. And now what will happen? We will increase y value, which will increase literally by the fact the value of x. And that value of x will be just, given back here. Surely, right now, you see, guys, before executing the printf, all of components like the 1, 2nd, 3rd component, they had to be computed. So they were computed, and then the printf function was executed. So you see 6 increased equal to 6. Because actually we increased the original variable's value. So we call this method as a reference for the argument. Okay, well, here you have something pretty similar. The only thing the influence happens using ++ command, which I suppose you remember, guys. Things related to data types are not limited with some basic variables like integer, float, boolean, and so on and so on. We can have even arrays, and in case of the arrays, it's up to us to specify or not to specify the final size of the array. For example, I suppose, guys, you remember the bubble sort method, which we used previous time. I really hope you remember that. So here we have the function that basically takes the array of x and then resorts that by the bubble method. So what is interesting related to this one? It is interesting that working with functions make things in a bit interesting way. Well, I suppose here we have the problem. Here we have the error here in place of a. We had to have I suppose we had to have s. Give me a second. Oh no, we have array a. Okay, it was given. We had even a function print. It has s, but where this s is received. Yes. So print a, not print s, but print a. What is interesting? So you might say, well, we have the copy of the array, but array is a specific case, guys, and literally all arrays work as the reference. Let me give you an example. So I will have still the function increase, and I will have integer. Okay, let's call it a with maybe one value, right? So a 0 index will be equal to maybe 10. Okay, so I will say that, well, I'm having some array z as the second argument of this increase function. And what I will be doing, so I will be trying to reach to the array by the name of the z, and I will say, well, it will become 77. So looks like no big problem. Nextly, let's say that a0 is, and then we will have integer value. So let's make that a of the index 0, like this one, and let's see what we'll receive in the end. Okay, I had to give the arrays the second argument. So what did we receive here? A equal to 10. Oh, that's interesting. Maybe it's not working in this compiler. Okay, I suppose it just a specification of the compiler. Let's try to use a reference then. Okay, reference can be used for the array. Okay, that's frankly saying not what I expected. but I suppose that literally that's the matter of the compiler. So if you're using some other compiler, it might happen that that literally you will have the same result as it was expected to be received. Okay. Oh, here we have example of factorial function. So as you can see, it executes itself. So here we have a definition of function. Here we have an execution of function inside the definition of itself. But how it's possible to execute itself if when compiler will reach this line, the function compilation was not finished, because you see we still have a comment which has to be ignored, and we have the ending curly bracket of the function. Well, it's only due to a for declaration of the function. So only because of that. Okay, here we have a couple of descriptions about how that happens, that we were capable to make a factorial function. But again, it's super simple, guys. I really hope you got the point. And as all the time, we have to strengthen this this knowledge. So I will ask you guys to make couple of task solutions. Okay, maybe the task is not really interesting, but you have to make a several functions that basically give information of the length in centimeters, and one function should give you that size in millimeters. The second should give you that size in meters, and the third should give you the size in inches. So that will be the first task for you. And once you will finalize it, please guys put the code in the chat, or if you would not really like to do that, then you can just write that you finished that. As well as if you think that we have to take the first solution together, and you would like to see how I would make that, then as well you can just write that in the chat. Okay. Okay, I see that Benes is writing something. Yes, we can make the first one together. No problem. So we give centimeters, and we receive that value in millimeters, meters, and inches. I don't really remember what was the inch, what was exact size. 3 point something, I suppose. No, 2.54. Okay, 2.54. Okay, so what I will be having here, I will be having the function milli. Okay. I will have method, and I will have the function inch. As you understand, guys, since we're working with sizes, we cannot really work on integer values. So we will have to have at least floats for this solution. Okay. Now we can literally make a computation. So So what is the centimeter? Centimeter is much bigger than millimeter. Actually, 1 centimeter, that's 10 millimeters. So if we have 5 centimeters, we have to say that we have 10 times more millimeters. So the result of that will be x multiplied with floating point value. So that's why I'm writing here f. It will be 10. And we can even write the following. So some amount of centimeters is some amount of millimeters. And we can, for example, give 5. And we can find out amount of millimeters of 5 centimeters. So well, definitely they will be 5 and 10. We can compare that. Yes, 5 and 0. Why 0? What did I make wrong? Point this one. Yes. I have to use not integers but floating point values for the mask. Yes. So and if I do that, guys, I have to here between percentage sign and the mask, I have to say the number will contain like 4 symbols, and after the point from those 4 symbols, I will be using 1 symbol. Once we have pretty huge printout of those values. Let's run it again. Okay, we have to follow the format. So that 5 should be floating point value. Yes, 5 centimeters is equal to 50 millimeters. Okay, so about the meters, right? So as we remember, guys, the meter is bigger than a centimeter. So if we have 50 centimeters, we have 0.5 meters. So in 1 meter, there are 100 centimeters. So which means that amount of centimeters must be divided by 100. And by that, we will receive amount of meters, not centimeters. Let's see. So 5 centimeters will be 0.05 meters. So we have to play with these numbers after the point. And we need to give new line symbols as well. Otherwise, it's not really clear what's going on. So 0.05 meters, as I just told you guys. Okay, and we have inches, right? So let's find out how many of inches it is. So since 1 inch is equal to 2.54, if I'm not mistaken, centimeters. Yeah, 2.54. Then how is it possible to receive centimeters in inches? Well, we have to divide those by 2.54. 2.54. Yeah. And we'll receive inches. So in our case, it will be 2 point something, as we understand. Let's see the results. No, not 2 point something, but pretty close to 2. Okay, so 5 centimeters is equal to 1.97 inches. I forgot to write inch. 1.97 inches. So that's the way how we can make that. So guys, is it for us? Are we good so far? Okay. So since time is moving on and we don't have much time, so I would recommend you guys to try your skills and to train your skills in functions. And your task will be the task number 2. Write the program that asks a user to enter full numbers, line segments, length, and determine if there are true line segments which can create a triangle. Um, hmm. Well, I suppose this task is pretty interesting. But maybe not this time because time is limited. So I will give you this one. So you have to write the program which has a function swap, and it swaps values of two variable values which are given to the function. So if a previously was 10 and b was 5, so after you swap in a and b, a 5 and b should be 10. If previously they were 10 and 5. Is the task clear for you guys? Okay, great. So please make it, and when you will have the result, please share your code. Let's see how you implemented that. So how is the progress? Guys, if you're stuck at some point, you can always tell me, and we can make these things together if you will need that. Okay. Somehow I got replies only from Banis, almost only from Banis today. Okay, so good questions. Good question. What is about others? But it's okay, guys. Please keep working. Okay, so we have 10 minutes left. So is there anyone who made that task related to swapping function? Okay, then since we have some minutes, I will show you how you could do that. We will be working with the references. We will have a void function, and we'll call it swap. So it will assume x and y values, and we can give the references. So we will be modifying exactly x and y values. But how? We'll have some z additional variable to which we will assign x, then to x we will assign y, and to y we will assign z. Okay, so let's look how it can be used. Let's say we have exactly x, which is 5, and y, which is 10. So we will write them out using um, using percent %d, like for integers, and we'll give x and y for oops x and y for printout. We'll do printout maybe 3, but between them we'll be swapping values like this. Yeah, we have to give x and y as well. Yeah. Okay, so let's see how they will be used. Let's compile and run it. Yeah. So we have 5, 10. It's the first printout, then they were swapped. So they became 10 and 5. Nextly, we are swapping them again, and they become the original values. So now we have 5 and 10. If you will need this code, I will copy this code in the chat, so you could take that. All right, so 7 minutes are left, but I assume there is no need to maybe take another task. So maybe that's exact time for Q&As. So guys, do we have any questions related to functions? Maybe something was not really clear. Maybe you some additional examples. So guys, if you need, you can always tell it. As well as if you have some questions. So it's exact time to ask. Okay, I see that Benes is right, and probably there will be a huge question. Okay, let's wait. Okay, no questions. So you didn't understand the task 2 and then the other way and it just crashed. Okay, so since we have a time, please post your code which crashed and we can figure that out. But related to the task number 2, so you have 4 numbers, right? Just imagine you have 4 different lines, right? Or let's call them pencils. So the question is for you. Can you make a triangle using those exact ones? You have to know. Actually, it's the school math. You have to know that if only you have the case when one size sorry when one len when one of them is equal to, or let's call it, if one of them is less than other two summational len, then it's possible to make the triangle. So you have to create 4 if statements, like A is smaller than C plus B, then B is smaller than A plus C, then C is smaller than A plus B, and then you can integrate even a fourth variable, like it would be D. D is less than A plus B, D is less than I don't know, C plus A. Well, in a such manner, you can find out if those lines can form triangle. And why it is the only case? How you can figure that out? Because you can imagine if you have pretty big I don't know line, um, and it's bigger than two other summational len, so how they can be combined? There's no any single chance for that. Okay, I don't have any practical example here to show you. Oh, okay, I have one. So I have pretty small 2 pencils, and I have a screwdriver. So let's say you have 3 lines, right? These 2 and this one. So take a look. We attach one line to the end of the biggest one and another here. As you can see, the screwdriver's line is super big. So these 2 small lines, they're not crossing, like they're not touching each other. So that's the only case in which triangle cannot be created. Does it make a sense? Okay. Okay. All right. So since there is no code in the chat, so I suppose you wouldn't like me to take a look on your codes. Okay, that's fine. All right. So and as I understood, all others don't have any questions. Okay. Well, I really hope today's class was clear for everyone. I really hope that. If it was not really, then please go through again materials. And next time we will finalize the topic related to certain algorithms. We will be using functions at purpose. Okay, guys. So thanks for attending this class. I really hope you enjoy them. And we just have to move forward, trying more and more, and coding more and more. Okay, guys. Again, thank you. I really appreciate that you appear on these classes. And we'll meet next time. Next time we continue working on the stuff. Okay, thanks again and have a nice evening, guys. See you next time. Bye-bye.